This time we're looking at another problem which has voltage, current, and power involved. This time we have a device. Let's say this is our device, and the voltage across the two ends of this device, plus and minus here, is voltage V. And the current that's flowing through this device is along this direction. So if that's how it is, and suppose we have the voltage given as a time function which is 3 times e to the power minus 2t. The unit, of course, is the voltage V. And now if the power consumed by this device is given as P equals 60, also a time function here. So 60 e to the power minus 4t. Now the unit of power is of course watt after James Watt. So if we have to determine the charge Q collected from time t equals 0 to time t equals infinity, t approaching infinity, we wait long time, and of course it's I dt, then we would have to combine the power and the voltage to figure out I. How would we do that? If you recall, the power is given by voltage times current. Okay? Now what we have here is power and voltage already defined and given to us. So using as such, the current is primarily the ratio of power to voltage V. We have the power expression, so, and we have the voltage expression as well. So that what that means is, based on this info, we have Q equals, let's go ahead, put the units. So I is power over voltage. So 60 e to the power minus 4t divided by 3e minus 2t. So basically we have the power expression and then divided by the voltage expression to give the current I. Then we also have the variable dt. So as we simplify this, it's primarily 60 over 3, which is 20, e minus 40 on the top, e minus 2t on the bottom. So that gives us a balance of e minus 2t dt. Folks, right here, if we wanted to use the dummy variable t prime, we could. But the upper limit is infinity, so we're fine. Next step is to take the 20 as a common. It's a factor outside the integral. So when we integrate, the exponent has 2 on it, so we would have to pull it down 1/2. Then e minus 2t. And when we throw in the limits, because of the minus, we could swap the upper to lower and lower to upper limit. So that will take 0 to the top and infinity to the bottom. So that will give us 20 over 2, which is 10. Okay. And then we have e to the power minus 0 minus e to the power e minus infinity. E to the power of 0 is 1. E to the power minus infinity, of course, is 0. So it's a 1 minus 0. 10 times 1 minus 0 is primarily 10. Meaning the charge collected Q, starting from the time t equals 0 to a time which is very long, we wait and wait and wait. And then at that point in time, we have the charge collected given by 10 coulomb. C is to mean coulomb. So that is the answer for this problem. To recap, this problem shows a situation where we have a device, a two-terminal device, an element, and we have an information about the voltage and the current indirectly by way of voltage and power given to us, and we use the integral as we have been to determine the charge collected over a long period of time. That's the deal here. Hope you enjoyed listening to me and seeing the problem I just did. I had a wonderful time explaining about it. Well, thanks for listening. Take care. Bye.